Oh, that's too loud. Right. So can you all just remind me if we have gone through question 12, or is that something that I asked you to do? Oh, okay. I think we've gone through question 12 together. Yes? Did we finish question 12, Yadi? Yes, I think so. Okay, the next question that I want to go through with you, or that I want to help you, would be question. So some of these questions you will notice that they are polymerization. We didn't finish question 12. So which part did we do so far? It's like I'm talking to myself. D and E balum. Okay. Right. Skeletal formula of compound D. So have I given you the answer to compound D? Because you wouldn't be able to do compound D without me giving you the hints, because that's not something that you have done. Okay, so compound D is this CH3CO COCH3. Yeah, I just accepted Ridwan. Ridwan just joined us. Ridwan, we are now looking at question 12 of our exercise 14.2. Okay, you may mute your audio, but if you have anything to say, then just interrupt me or
Okay.
say something. Okay, because I will be looking at my iPad most of the time anyway, so I might not be looking at the main screen. Right, so the structural formula for compound D is given there, and you are expected to draw the skeletal formula. Okay, I'll leave that for you to try. This one, draw the skeletal formula of compound D. So please make sure you copy this down first. CH3CO COCH3. Again, I repeat, don't worry if you miss anything. Everything will be recorded and I will be uploading them to YouTube, just in case you need to revisit this class or this lesson. Okay, by using letters A to D as appropriate, identify those compounds which are chiral. If there are none, write none. Again, there is, I can give you a hint that there are actually two molecules or two compounds with chiral centers. So I will let you decide that. E is a polymerization question, which is still in your syllabus, but it's not covered in this topic. So that will be covered in a topic that we will visit later on. So I'll just skip that for now. Do you have question F with you? Or is that just on mine?
Video.
You do, okay. Right. So compound C is a liquid which can be reacted with concentrated sulfuric acid to give a gas E, which will decolorize aqueous bromine. Okay, so this is a good hint. Gas E will decolorize aqueous bromine. Sorry, that's not. Okay, we'll skip that. Yeah, we'll skip that. Okay, so you have that question D to do, right? If you don't have time to do it now, you can continue later on. The next question that I want to look at is question, I don't remember the question number. Okay, question 17. So that means I have to add this. Okay, so question 17. The molecular formula of a compound states the number of atoms of each element that are present in one molecule. So that's just a definition. It contains no information about the structure of the molecule. C5H10 may be branch chain, straight chain, or cyclic. Okay, so straight chain means all your carbon 5 are arranged in a line along the principal chain. Okay, branch chain means your principal chain changes. Okay, what do I mean by this? Now, if you compare the straight chain, you have 5 carbon atoms in the principal chain. Whereas if you look at the branch chain, you now have 4 carbon atoms in the principal chain. So the moment the number of carbon atoms change in your principal chain, that means they are branched. Okay, so just to remind you again what a principal chain is, a principal chain is the longest chain of continuous carbon atoms. So in this case, that's a principal chain. And for the branch chain, carbon with 4 atoms is your principal chain. Cyclic chain is in a ring. It is all the carbon atoms are connected to each other. So if I show you a cyclic carbon with 5 carbon atoms, it would look like that. Okay, so I have omitted the hydrogens. So draw a displayed formula of C5H10 as a branched chain hydrocarbon. So I think there are many possible answers to this, okay? But the question is only asking for one. So this itself is already the answer, but be careful because the question says displayed formula. Now, displayed formula means showing all the bonds. So this means that you have to draw out all of the bonds, including the CH3. Okay, so there are many possible answers that can be accepted, but only one. You just have to draw one. And this, I think, would be the easiest one. Okay, pen to in. I'll let you copy that down first. When you're done, please let me know, okay? Okay, thank you. Right, next, pen to in. So the in gives you a hint that it is a double bond, is one straight chain hydrocarbon. So it's a straight chain with formula C5H10. Okay, so you have to draw the structure of pen-2-in correctly. So the principal chain is pentene. Okay, pent means 5, and also because it is a straight chain, you don't have any branching. Okay, and then your double bond is located on the second position, second carbon. So 1, 2. So it's between 2 and 3. Okay, so this is your pen to in, and they want you to draw the cis trans isomer. Okay, so I believe all of you should be able to do that, to draw the cis trans isomer. So can you please do it now? Okay, so the thing with this draw and label the structure formula. So they only say structural formula. It doesn't say displayed formula. So you do not have to draw all the hydrogens and draw all the bonds, okay? With double bonds, and especially when you are drawing cis and trans, you want to put the double bond in the middle. So like this, C double bond C, and then everything is hanging off it, okay? So if you just focus on the carbon of the C double bond C, you highlight that and put it in the middle, and everything that hangs off it, okay? So we know that our double bond is between carbon 2 and carbon 3. So everything else is just hanging off that. And what's attached to carbon 2? CH3. What's attached to carbon 3? You have a hydrogen and you have a CH2CH3, okay? Now it says structural formula here, so that means you cannot write down C2H5, okay? C2H5 is not a structural formula, so we don't want you to do that. Okay, you have to write down the structural formula that is the atoms according to its arrangement. So that means after carbon 3, you have the hydrogen. Okay, that's done. And then you move on to the other bond where you have a CH2 followed by a CH3. Okay, so this is one type of cis-trans isomerism, okay? So you label, you have to draw and label, so make sure you do the labeling. I've already drawn one for you. And how do we know which one is cis and trans? You have to choose a priority group on each carbon of the double bond. So first we start with carbon number 2, and we want to choose, there are only 2 bonds that are hanging off carbon number 2, and we have to choose one that is heavier. okay, that is bigger in MR or heavier. So in this case, it's between hydrogen or CH3. So obviously your CH3 is heavier, so it becomes a priority group. That's the priority group of carbon 2. Moving on to carbon 3, we want to find the priority group again. You have hydrogen and CH2CH3, which is an ethyl group. Okay, so this is considered an alkyl group. So obviously CH2CH3 is a priority group. So because the priority groups are on the same side, we call this cis. Okay, so I have drawn the cis isomer for you. Sorry. So now you have to draw the trans for me. Okay, make sure you label, this is the cis isomer, and then you will draw for me the trans isomer. Let me know when you're done. Okay. Next is in the spaces below, draw the structural formula of two alcohols, which would each produce on pen-to-in on dehydration. So you want to draw the alcohols that will produce pen-to-in. So now we are going in reverse. Okay, so we want to find this. Sorry, no. Okay, to form pen-to-in is this, right? So there are two, okay, two alcohols that would produce pen-to-in, same thing. Okay, we are not concerned with the cis and trans here. Okay, we don't have to worry about the cis and trans here, but we need to find the two alcohols that would give this pen-to-in. Okay, so that process is called dehydration, right? So if we are working in reverse, it would have to be the opposite of dehydration. So now we are doing hydration. Okay, hydration means you are adding water. So when adding water or adding things across the double bond, if you still remember, you have to add one bond per carbon. Okay, so one carbon will get a hydrogen and the other carbon will get an OH. You can't just add H2O like that. Okay, so it has to be one being added a hydrogen and the other one being added the OH. So why are there two alcohols? Because of the possible position. Okay, there are two possible positions where you can put the hydrogen and where you can put the OH. Okay, so as you can see just now, I've decided to put my hydrogen on the second carbon and the OH on the third carbon. So what if I swap the position? OH is now on second carbon, hydrogen is now on the third carbon. And if I look at these two compounds, and if I inspect them, they are two different compounds. Okay, so that means my alcohol would be this 1, 2, 3, 4, 5. So I'm going to number my carbon just in case, because that was where my double bond was. Okay, so I put hydrogen here, OH here, or the other possible combination is OH on the second carbon and hydrogen on the third carbon. Okay, so these are the two alcohols that can give or that can result in the same product. Okay, so I'm just going to erase that because both of them will give the same product anyway. Right? What happens? Okay, so now I'm going to show you the dehydration process. Sorry. So during the dehydration of alcohol, which is something that will be covered again in the next topic, in the next two topics, but you have this in your notes. If you want to look for this in your notes, it should be under production of alkenes. Okay, I don't have my notes with me, so I don't know which page it is on. So if you're looking for this part in your notes, it should be under production of alkenes. Okay, specifically under the dehydration of alcohol. So what happens during dehydration is that you will lose water. Okay, dehydrate, lose water. So how do we lose water? We lose OH from one carbon and we lose hydrogen from the neighboring, okay, from the adjacent carbon. So in this case, because I lose OH on the third carbon and I lose hydrogen on the second carbon, so my double bond, of course, I will have one less bond on that carbon. So in order to make that carbon happy with 4 bonds, it needs to have a double bond there. Okay, I don't know if you remember this, but this is definitely something that we have covered already. Okay. Same thing for the second molecule. You also lose OH on the second carbon and hydrogen on the third carbon. All right. Question is, are these two alcohols the same or different? They are different because if you look at the first molecule, your hydroxy group is on the third carbon. And for the second molecule, your hydroxy group is on the second carbon. So these two are different alcohol and they are in fact isomers. They are called the positional isomers because the position of the hydroxy group changes. Okay, right. Okay, I'll move on because we are running out of time. I think we only have 5 minutes left or less. One of these alcohols exhibits optical isomerism. Draw the structural formula of the two isomers of this alcohol. Your structures should clearly indicate three-dimensional. Okay, remember for this question, when you are asked to draw the optical isomer, you need to draw them in 3D. Your guide is to start with a skeleton, not a skeleton, with a 3D tetrahedral structure first. Okay, you start with drawing this, and then only you look at what are attached to that particular chiral carbon. Okay, so one of these alcohols, so we're referring to the alcohols that we were looking at. So one of them has a chiral center. Okay, either the one at the top or at the bottom. I'll let you decide, right? So of course, there's only one of them. Only one of them can have chiral center. Okay, so when you draw them, please draw them correctly. Make sure you draw the structural formula. Structural formula means, again, CH2, CH3, for example. Okay, no shortcut such as C2H5 like that. Okay, yes, Danish, you're right. So draw that, okay? Draw the alcohol that has the chiral center and then draw the mirror reflection. Okay, again, if you think you will get confused easily, just draw the bonds as it is reflected. Okay, everything else, you just fill it in. Make sure they are the same arrangement as the molecule on the left. Okay. This meeting will end in 10 minutes. Okay, right. That's fine because we are going to, I'm going to end this session soon, but I will just give you some hints in order for you to complete this question. So on to the next one. Okay, if you're still on question D, please continue that later on. I just want to talk about question E quickly, right? Pent to in decolorizes aqueous bromine. Suggest the structural formula of an isomer of C5H10 which does not decolorize aqueous bromine. Now there's a problem with this question because they're actually asking you for an alkene, an alkane with the formula C5H10 and that it doesn't decolorize bromine. What is the problem with this is because bromine, alkanes can actually react with bromine in the presence of UV light, as you all know. Okay, so the problem is actually with the question. They should say it does not decolorize aqueous bromine in a dark room. Okay, can you add that to the question? Otherwise, alkanes in the presence of sunlight, in the presence of UV light, will be able to react with aqueous bromine. Okay, so that's why I just want to add that last statement so that you don't get confused. Okay, now the question is, what structure of alkane would have a formula of C5H10? Because usually alkanes, technically alkanes, based on its general formula, would be C5H12. Okay, and it doesn't have a double bond. Okay, it must not have a double bond. Right, so the answer is actually in the cyclic alkene. Okay, so if you count this, 1, 2, 3, 4, 5, 6, counting the number of hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that is the answer to this question. Now, structural formula. How do you draw a structural formula for this? So you just draw it like that. Okay. Do we show the bonds? Yes, you show the bonds because it is a cyclic molecule. Okay, try not to yes, Danish, well done. I just read your answer. Try not to write down the structural formula like this because 1, 2, 3, 4, 5, because there is a connection between that, the first carbon and the fifth carbon. Okay, so we don't write it in a straight line. We show the bonds instead. Okay, so that is all for today. We did question 17. Okay, we complete question 17. Well, we haven't completed. You have to complete question 17. And then what happens is that, let me just stop the recording first because I don't want this to be recorded.